The lead in and lead out feed rate plus the ramping feed rate can now be defined independently of the main cutting feed rate. This means we can now precisely control the entry and exit feed rate of the tool into the material, thus reducing the risk of damage to the tool, reducing the overall wear on the tool and increasing the tool life, and also reducing the risk of damage to the part, especially when cutting brittle materials such as graphite. Let's take a look at an example of setting the lead in and lead out feed rate and the ramp feed rate independently. So on the screen we have a flat machining toolpath which has a ramp down onto the flat surface, which we can see in the light blue colour. Now this toolpath does not have any independent ramp feed rate set, and if we look at the feed rate form, we can see that the cutting feed rate is at 3000 millimeters per minute and the plunging feed rate is at 1000 millimeters per minute. Now let's say, for example, we would like to set the ramp feed rate at 50% of our plunging feed rate. So to set an independent ramp feed rate, if we go to the settings for our toolpath, and if we recycle the toolpath and expand the feeds and speeds, we can see there is a new lead feed rates option. If I select that, there are three feed rates we can set independently: the ramp lead in, the lead in and the lead out. Now these can be defined either as a percentage of the plunge feed rate for the ramping or a percentage of the cutting feed rate for the lead in and lead out. Or alternatively, we can define an explicit value by typing it in the highlighted box. So in our case we want to set our ramp moves to 50% of our plunging moves. So our plunge is 1000 at the moment, so I'm going to set the percentage to 50, and you'll notice the other field updates automatically. So if I calculate that now, so now the feed rate for the ramp moves is now set at 50% of the plunging moves. So let's just post-process that toolpath so we can see the output. So I'm just going to drop that toolpath into the NC program and then write. So that's now been post-processed, so we can view that file. Expand the box here. So you can see here we're using Q values to define our different feed rates, and our plunge feed rate is Q1, which is 1000. But you can see here we have a feed of 500, which is the ramp move, which ramps down onto the part, and then we have the Q2 value, which is the cutting feed rate. Let's take a look at another example, this time a finishing toolpath, a swarf toolpath, to swarf the outer wall of this part. Now again we have no independent feed rate set for this part, and if I undraw the part and undraw the tool and we look at the feed rate, if we draw the feed rates, so say edit, drawing options, draw feed rates, you can see that there's just one colour for the whole toolpath, including the lead in and lead out, indicating that everything is being cut at the 3000 millimeters per minute. So now we're going to set an independent feed rate for the horizontal arc in and the horizontal arc off. So if we go to the settings for the toolpath, recycle it, select the surfaces for swarfing, again look at our lead feed rates. So this time we're looking at the lead in and lead out, not the ramp. So we want the lead in to be a lot slower into the material, so I'm going to set that at 25% of the cutting feed rate. And the lead out does not need to be as slow as the lead in, so we're going to set that at 50% of our cutting feed rate. So if we now calculate that again, so if we undraw the part now and we go back in and draw our feeds, you can see we have three different colours now, indicating there are three separate feed rates. The lead in, which is the light blue, which is done at 25% of cutting feed rate. The brown, which is our cutting feed rate at 3000 millimeters per minute. And then we have the darker blue, which is done at 50% of the cutting feed rate, so that's at 1500. Again, we'll post-process that so we can see the output. And then view file. So here we have our Q1, Q2, Q3 values, etc. So our cutting feed rate is 3000 and our plunge feed rate is 1000. But we can see here clearly we have a circular arc interpolation at feed rate of 750, which is our lead in. And then if we scroll down, we have a circular arc interpolation for our lead out, which is done at 100 and a feed rate of 1500. So to summarise, we can independently now control the lead in and lead out feed rates either by a percentage or an explicit value, and we can also do the same for the ramping down onto the part.